In this video, we're going to be looking at systems of linear equations. We're going to be looking at what they are, how to solve them using 3 different methods, and also walk through multiple examples. So let's start with identifying what a system of equations is. So a system is 2 or more equations that you solve together at the same time. What is our goal in doing this? We want to find the values of variables that make both equations true at the same time. So we're going to have 2 variables, for instance, let's say x and y. We're going to be looking at the point where those 2 lines will intersect, meaning that our x values in both equations and our y values in both equations will be the same. So there's a couple different solutions we can get when we're solving systems. So the first one is we're going to have one solution. This means that the lines intersect. So we're gonna have an intersection at one point, is what that means. The second one is having 0 solution or no solution. This means that the lines are parallel. So if we have no solution, that means that there's no x and y value that is the exact same for these 2 lines. That only happens when they're parallel. And then the last one we can have is infinite solutions. This means that they are the exact same line. Infinite solution means that every x and y value, they are the exact same. So meaning that they're on top of each other. So let's look at the 3 different ways that we can solve these systems of linear equations. So the first example we're going to look at is graphing. This is when you want to have a visual of what you're solving. It's not very precise though. So if we have decimals, numbers that just aren't friendly, it's not going to be as easy to tell what they are from this graph. So you would want to do graphing typically when you don't need an exact answer, maybe an estimate. Like I said, maybe you just need a visual. Or if you see things in a format that's very easy to graph. So if we look at these 2 equations that we have here, y equals 2x plus 1, y equals negative x plus 4, both of those are in slope-intercept form, which is very easy to graph. So we're going to start with our y-intercept. Let's look at our first equation right here, y equals 2x plus 1. We're going to take our y-intercept, which is plus 1, and plot it. And then we're going to look at the slope, which is 2. So we're going to go up 2 over 1, and then maybe we can go down 2 over 1 as well. And then this is just a rough sketch of what this line looks like. Now our second equation is y equals negative x plus 4. So let's graph this too. We're going to go to our plus 4 right up here, and then we're going to plot our slope negative x. So we're going to go down and over, like this. So we can see that there's one intersection point that looks to be at roughly 1, 3. So we would say that we would have one solution here, and our x value would be 1, and our y value would be 3. Like I said, if we have an intersection at a non-whole number, it might be a little harder to estimate, so this isn't the best approach if you need an exact value. But if our numbers are friendly and we need a visual, this is a great way to solve it. So the second method that we can use to solve a system is by substitution. And it's exactly what it is in the name. We're going to substitute one equation in for the other. So we're basically going to take one equation, put it inside the other one. You want to do this, it's best when one equation is already solved for a variable. So if we look at our system, this first one, we already have y, which is our variable, equals something. That means that we solved for that variable already. We know what y is equal to. So that means wherever we see a y, we can substitute a 3x minus 5 because they're equal to each other. So if we take this information in that first equation and plug it into the second equation where our y is, we eliminate our y and our only variable left is x. So it would look like this. Our new equation would be 2x plus, instead of y, we're going to put our first equation substitution, which is 3x minus 5. That's going to equal 4. If we combine our like terms here, we're going to get 5x minus 5 equals 4. And then we're going to solve for x. So we're going to have 5x equals 9. Divide by 5. And x is going to be equal to 9 over 5, which comes out to be 1.8. So now we have our x value. We know what x is equal to. So what we can do is we can plug it into the either equation and get our y value. So I'm going to plug it into our first equation because we're trying to figure out what y is equal to as a numerical value, and we already have y equals 3x minus 5, so we know what y is in terms of x. It's just that at the beginning we didn't know what x was. Now we know what x is, so we can just plug in 1.8 for x over here, and then we'll get y equals whatever our numerical value is. So it'll look like this. We'll have y equals 3. Instead of x, we're going to say 1.8 minus 5. And y is going to come out to be 0.4. So that means we have, again, one solution with our x value being 1.8 and our y value being 0.4. You could have changed this second equation to have it be y equals something. That would put it in slope-intercept form, and then we could graph it. But if you look at the answers that we got, it's very difficult to estimate that based off of a graph. So in this case, substitution's a better way. So the third and final method that we're going to look at today on how to solve these systems is going to be elimination. So elimination is when we're going to combine our two equations together to eliminate one of our variables. So what we're going to do is we're going to look at both of our equations, see if when we combine things, we have a plus constant value and a minus same constant value. So when we combine them, it zeroes out. If not, we're going to want to manipulate one or both of these equations by multiplying by something in order to get it to that point. So if we look here, we have a 2x and a 4x. Right off the bat, when we combine them, they're not going to cancel out. But if we need to eliminate our x value, we know we can just multiply our entire top equation by -2, because that'll give us a -4x. So when we combine that -4x with that positive 4x, we're going to end up with a 0, hence our x is going to be eliminated. But let's look at our y values for now. We have a plus 3y on the top, minus 3y on the bottom. They will cancel out if we combine them. Plus 3 minus 3 is going to give us 0. So our y values are going to cancel out in this system. So let's combine them. We can just essentially put a plus sign here and get 6x plus 3y minus 3y gives us 0. So 6, 3 plus 0, you don't have to write that, is going to equal 18. So we have 6x equals 18. Now we can just solve for x. So our x value here is going to be 3. And then we're going to do the exact same thing that we did for our substitution. We're going to take our value that we have, in this case it's x equals 3, and we're going to plug it into one of our two equations. So I'm going to again pick the first one, and instead of x, I'm going to put 3, since I know x is equal to 3. So I'm going to say 2, instead of x, I'm going to put a 3, plus 3y equals 12. 2 times 3 is 6, so it's 6 plus 3y equals 12. I'm going to subtract 6 from both sides, so 3y equals 6. Divide by 3, and our y value is 2. So again, we only have one solution. We have x is equal to 3, y is equal to 2. Let's look at a word problem application now. So it says you buy 5 tacos and 2 burritos for $19. Another day you bought 3 tacos and 4 burritos for $18. They want us to solve how much is each taco and each burrito. So we can say x is going to be our taco and y is going to be our burrito. So we know that if we buy 5 tacos, so that's 5 x's, 5 tacos, and 2 burritos, so 2y, so we have y as our burritos times 2 because we have 2 of them, it's going to equal $19 total. We also know if we have 3 tacos, so we're going to say 3x, and we also get 4 burritos, so 4y, that's going to equal 18. So we look at our information that we're given, and we're going to form a system of linear equations from that, and then we want to choose the appropriate way to solve. So right now I'm not seeing anything in slope-intercept form right off the bat. Both of these are in standard form, so I would not use the graphing method. So from here, we can either do substitution or elimination. If we look at our x's, we have a 5x and a 3x. That's not too easy to cancel out. We'll have to get a common factor of 15. If we look at our 2y and our 4y, they also don't cancel right off the bat, but it's a little bit easier because we just have to multiply our top numbers by -2, because then we'll get a -4y. So that's going to be the best approach to take here. If we multiply this entire top equation by -2, we'll get -10x minus 4y equals -38. So now what we're going to do is we're going to combine them. We have this 3x minus 10x, so it's essentially minus 7x. Our plus 4y minus 4y is going to cancel out. And then we have our 18 minus 38, which is going to be -20. So now we're going to solve for our x. We're going to divide both sides by -7, and x is going to be equal to 20 over 7, which comes out to be roughly 2.86. So this ends up being our price per taco. Now let's plug it into one of our equations and figure out what our y, or our burrito cost, is going to be. So now if we plug it back in, our 2.86, let's plug it into this equation. If we plug it in, we're going to get 3 times 2.86 plus 4y equals 18. Now we're going to do 3 times 2.86, giving us 8.58. And we're going to add that to 4y to get 18. Now we're going to have 4y being equal to 9.42. When we divide by 4 now, we're going to get y is equal to 2.36, roughly. So we end up with the tacos being $2.86 each, and each burrito being $2.36. We can also check our work to see if we're correct by plugging in our x values and our y values into both of the equations to make sure it works. So it would look like this. We'll take our first equation and replace it with our x and y's. So instead of x, I'm going to put 2.86, and instead of our y, I'm going to put 2.36. And if you were to do this math on a calculator or by hand, you will end up with 19 equals 19, meaning that the first statement is true. If we look at the second one, we're going to do 3 times 2.86 plus 4 times 2.36, and that should equal 18. Again, if you do this by hand or in a calculator, you'll end up with 18 equals 18, meaning that the second equation is true, so the x and y values work for both equations. Let's look at one more example, this one working with trickier fractions or decimals. So we have 0.5x plus 0.25y equals 2, and x minus 0.5y equals 1. When I see this, the first thing I'm going to want to do is work with whole numbers. So the easiest way here is by elimination, because we didn't solve for a variable already. We don't have x equals something or y equals something, and nothing's in slope-intercept form, so it's not worth it to graph it. So the best way is elimination in this case. So I see that I have a 0.5x here and an x here. I can multiply my bottom equation by 0.5, a -0.5, and then they'll end up canceling out. But I'm still going to be working with unfriendly decimals, which I don't necessarily want to do. So instead, I'm just going to get everything to eliminate at the whole number. So I'm going to take this top equation, and I'm going to multiply it by 4. The reason I'm going to do that is because we have a 0.25y. That's the equivalent of 1 over 4. If we multiply 1 over 4, or 0.25, by 4 by its reciprocal, we're going to end up with the whole number 1. So that's what I'm going to do here. And then on the bottom, I'm going to multiply everything by 2. And that's because I have this 0.5y in the second term. If I multiply by 2, which is the reciprocal of 0.5, which is 1/2, I'll get the same whole number 1. And then we'll have a plus 1y on the top, minus 1y on the bottom. So it'll work out. So if I rewrite my top equation, I'm going to end up with 2x plus y equals 8. So I multiplied the 4 by the 0.5, the 4 by the 0.25, and the 4 by the 2. I'm going to do the exact same thing, but with the number 2 on the bottom. So 2 times x is going to give me 2x. 2 times negative 0.5 is going to be negative 1y. And that's going to be equal to 2 times 1, which is just 2. So now I can combine these and then solve for x. So I'm going to get 4x, this plus y and minus y are going to cancel out, is equal to 10. If I divide by 4 to get x by itself, x is going to be equal to 2.5. This is now my x value. So since I don't want to work with these fractions or decimals, I'm going to look at what I wrote here in the blue, and that's what I'm going to plug this x value that we found into. So I'm going to take the first equation again. So we're going to